Hey class, last projectiles video for this week at least. We got a bunch more next week, but for this week at least. So I'm going to go over 2 more questions from the practice work to just look at how to tackle the projectiles questions, how to break it down, and hopefully try to understand it. So let's go and do that. Let's do this. And we got this little one. All right, so this is question 3. From our practice question. It says an object is thrown horizontally at a velocity of 18 meters per second. So my Vx equals 0, my Vy equals 0, my Vx equals 18. I don't know if I just said 18 or 0 twice. Vx equals 18, Vy equals 0. So from the top of a cliff, we are at the top of a cliff. This is our cliff. This is our person. All right. If the object hits the ground 100 meters from the base, so now we have this. Okay, we have it hit 100 meters away. Okay, X marks the spot. That hit 100 meters away from the base of the cliff. All right, how high is the cliff? All right, well, we don't have a whole lot to work off here. Let's try and see what we can do here. The first thing that we're probably going to have to do here is figure out, again, time. We got to figure out some kind of time. And the nice thing is we have a Vx, like in the x direction, a velocity in the x direction. We also have a distance in the x direction. And that velocity is constant. It's not changing, which means we can nicely, anytime we get a velocity in the x direction and a distance in the x direction, we can use this. Distance equals time multiplied by velocity. That nice, easy formula. We don't have time, but we do have a distance in that x direction. 100 equals time multiplied. We do have a velocity in the x direction. 18. So divide by 18. Divide by 18. And our time is going to be, if I have an answer here, 5.56 seconds. 5.56 seconds. All right. So I have the time that it took to go down. And it doesn't matter, again, if it went 100 meters or 1,000 meters or 2,000 meters. If you get that same exact time, the distance up and down is going to be exactly the same. So now that I have this time, I can work backwards, okay? What else do I have to work with here? Okay, now that I have a time, it's not going to open for me. There you go. Time equals 5.56 now. I know my acceleration is always 9.8. Okay, and I have my Vy there, which is 0. So again, I'm going to use that. D equals, leave it here, Vit plus 1/2 at squared. Okay, and let's plug this in here. So I don't have my distance. Equals Vi 0 multiplied by time of 5.56. It's going to cancel out. Plus 1/2, 9.8. 5.56 squared. All right, so that goes to 0. I get 4.9, like a half times 9.8, times 5.56 squared is, no, I don't have that actually on here. Well, eventually, here, one second, I'll figure that out fast. I just went right to the answer when I was doing my work. I should probably write this down. 5.56 squared equals, there we go, 30.9. 30.9. When I multiply those two together, I get a distance of, I have that answer, 148.2. Nope. 151. Sorry, 151.4 meters. 151.4 meters. Okay? So there you go. You can get the time as long as you have 2 x components, your distance and your velocity. You can get your time right away, and then you can figure out that distance of the actual cliff. Cool, cool. There's example 1. Let's go to question 7 now, which is a little different. Question 7. All right, there it is. Question 7, it says, an object is thrown horizontally from the top of an 85-meter building. 85-meter building. Our distance in the y equals 85 meters. Cool. If the object hits the ground 67.8 meters away. 67.8 meters. There's my x. So my dx equals 67.8. Okay, I know my acceleration. What was the horizontal velocity of the object? What was the horizontal velocity? So basically, again, this is thrown horizontally off, which means my Vy will automatically be 0. I don't know my time. I don't know my Vx yet. So let's try and figure this out. What could I do here? Well, the thing is, if I know the distance that it's dropped from, I can figure out my time, right? Anytime I have a distance, I know my acceleration is going to be, I know my Vy is 0 right now. So let's just figure out the time that it took to drop. All right, this formula again. So I have my distance 85 equals Vi of 0. I don't know my time yet. Plus 1/2 9.8 times squared. This cancels out. 85 equals 4.9 times t squared. Divide. And what do I get for that? Question 7. There we go. 17.35. 17. Let's write 17 properly. 17.35 square root. And my time equals, I think it is 4.16. 4.16 seconds. So, it took 4.16 seconds to drop because we know the height already. We know the y direction is going to be the same time-wise no matter what. So that is the time. Now, like the nice thing is, time is not going to have an x or y value. You can't go so much time in the x and different time in the y. So this is always going to be exactly the same. Now that I have that time, 4.16. And again, I don't know my Vx, but I do know my distance in the x direction. So to figure out the Vx, again, I can go back and use this formula. Distance equals time multiplied by velocity. I have the distance, okay, right there, 67.8, and I have the time, so I can figure out the velocity at least in the horizontal direction. All right, so let's plug this in. 67.8 equals 4.16 multiplied by velocity, so divide, cancel out, divide. And my Vx equals 16.3. Wherever this was, threw the object off horizontally with 16.3 meters per second. And that's a pretty fast speed. So there you go. There's our second example, how to answer basically projectiles with just horizontally. Okay, you're going to usually end up having something like this and some kind of d equals dv. All right. Cool. I think someone's trying to sneak in here and get some work done, so it's all good. We're good for today. If you have any questions at all about this week, let me know, and I can definitely help you. Thanks so much, class. Have a great week.